In this video, we're going to solve the system of equations xy plus xz equals 1, xy plus yz equals 2, and xz plus 2yz equals 3. We're going to find all pairs x, y, and z. Also, don't forget to subscribe and turn on notifications so you don't miss a video. Okay, from the first equation we have that xz equals 1 minus xy. Now you see that xy appears in the second equation, so let's just solve for yz. So that yz will be 2 minus xy. Now we can plug these two things into the third equation, leaving us with xz, which is 1 minus xy, plus 2yz, which is 2 minus xy, equals 3. So this will be 1 minus xy plus 4 minus 2xy equals 3. Negative xy minus 2xy is minus 3xy. We have 1 plus 4, which is 5. So this would be 3 minus 5 is negative 2 on the right-hand side. Dividing by negative 3, you get xy equals 2/3. Okay. So xy equals 2/3 tells us that xz equals 1 minus 2/3, which is 1/3. It also tells us that for solving for yz, we have that yz is 2 minus xy, which is 2/3, which is 6/3 minus 2/3. You subtract the denominators, the numerators, sorry, so you get 4/3. Okay, so we have xy equals 2/3, xz equals 1/3, and yz equals 4/3. So this is another system of equations, technically, but not as bad. So let's solve for, so let's check if x equals 0 first. So if x equals 0, for the original equation, we'll get, well, 0 equals 1, so that doesn't work. So 0 does not equal 1, so that doesn't work. Let's check if y equals 0. So we're going to get 0 equals 2, so that doesn't work, obviously. So if we have z equals 0, we have that 0 equals 3. Okay, so none of these can actually be equal to 0, so that's really good. So we can divide by x, y, and z and not worry about dividing by 0. Okay, so let's say this is equation 1, equation 2, equation 3. So if we have equation 1 divided by equation 2, we will have the x's will cancel, right? Leaving us with y over z equals 2/3 divided by 1/3, which will just cancel out the 1/3, so this will just be 2. Okay. So that means that y equals 2z. Okay. Now if we divide equations 2 by 3, we will get, so that would be x over y equals, because the z's will cancel, leaving us with 1/3 over 4/3. Again, the 1/3 will cancel, leaving us with 1/4. Okay. So we can cross multiply these, leaving us with y equals 4x. If you don't want to cross multiply them, you can just take the reciprocal, so y over x equals 4. Multiplying by x, you get y equals 4x. Okay, that's good. But this is equal to 2z, so z is really 2x. Okay, divided by 2. So once we get x, we can solve for y and z. Okay. So going back to the original equation, which is all these. Okay, so we have that x can be by itself, y equals 4x. So we have that y equals 4x, and z equals 2x. So we can just plug that into the original equation, leaving us with, so we have 4x squared plus 2x squared equals 1, which tells us that 6x squared equals 1, which also tells us that x squared equals 1/6. Taking positive and negative plus or minus the square root, you get x equals plus or minus the square root of 1 over 6. Okay, so we have that x, y, and z. So these can be two things. So this will be square root of 1 over 6, which we can write as 1 over square root of 6. Now the y will be 4x, and the z will be 2x. Okay. So you can simplify this. So 4 times 1 over, this is just the 4 being on the top, so this would be 4 over square root of 6. and then we have 2 over square root of 6. And then the other answer will be 1, so it will be the negative version over square root of 6 because x is plus or minus, and then we'll have negative 4 over square root of 6 and negative 2 over square root of 6. And you can simplify these and rationalize the denominator, but that is the end of the video. Hope you liked it, and thanks for watching.